Thank you, Guillaume. I'm going to do something that is very unusual on these meetings, that I'm going to share some slides that we have here. So bear with me. Yes, I found the correct deck. So as Guillaume was saying, I will present why Sylva, our approach, and then I'll pass to the validation center to Mathieu for the part of explaining the platform, and then Luis to explain the validation center. We are very comfortable in terms of time, so if you have questions, you can raise your hand or you can put it in the chat, and we'll try to reply to everyone. Okay. We also want to have this Q&A and for you to understand the project and join the project, of course. So I'm going to share here. I think you can see it, right?
Yep, it's visible.
Yes, I can see.
Perfect. So as any project, why we need Sylva and why this project appeared? We've been seeing in terms of CSPs to the journey of the telco cloud and the edge that began almost a decade ago. Some of us were in the beginning of when this transformation, digital transformation in the operators and the edge. But we still have some challenge after a decade of virtualization of the network. One of them is the siloed approach. So the model that doesn't fit the multi-vendor approach, and we couldn't shift to a common cloud layer due to the specifications of the VNFs and the CNFs. They are still very siloed. But also in terms of security threats, it's at most important when we do this virtualization and to guarantee that we have the security on the networks. We are dealing with very sensitive applications, and these applications can have serious issues when we're not correctly applied the security measures. So the operators are also every day increasing this security, and of course with the concerns of threat attacked by hackers. I'm from Portugal. We had an attack in the Vodafone Portugal 3 years ago, a very serious attack, and everyone was without communications for 2 days. And it was an hacker attack on the network. Then new network functions, things are evolving. It began the journey on virtual machines, but now they are evolving for not only on the core part of the network, for the RAN. In terms of applications, they are also being containerized. And all this journey of the network functions, it will implies more configurations and of course more standardization. So the shift also for the VNF and CNF needs to have this common layer to help the digitalization. Last but not least, the lack of automation. So the continuous innovation and service automation to shorten the time to deliver, and of course to reduce the OPEX. And this was one of the major flag points on the virtualization, to be faster not only to deliver a new service, but also to think about new services that we can have. A lot of hype being around the network slicing, but even from the mobile private network. So it's at most important that things being automated to be possible to satisfy the client demands. And with all these challenge, a group of operators and vendors joined together to design a mission statement below the Linux Foundation Europe project. It was created Project Sylva with the Orange, Telefonica team, Deutsche, Vodafone, Nokia, and Ericsson, with 2 major objectives. The first one, to release a cloud software framework tailored for telco and edge requirements that address the technical challenge of the industry layer of this ecosystem, to treat these very special network functions, to this very special software, but also to develop a reference implementation of the cloud software framework and create the validation program for this implementation, so everyone can have a certification of these network nodes. This is being created by the operators, but Project Sylva is not only for the operators, it's also for other companies that want to install and use virtual network functions on their use cases. And a lot of use cases are being appeared in the last year. So what opportunities that we want to unlock with these projects? So as current threats and dividing this by technology, business, ecosystem, and regulation, the current threats in telcos in terms of technology is the technology backwardness and slow innovation. And with Sylva, we want to include the open source mindset in terms of technology to improve the innovation, but also to have instead of proprietary solutions. But also to simplify and automate the operational model. And we see this collaboration from what we are seeing from since the beginning of the project, almost 2 years ago. We see a lot of collaboration and this Silicon Valley mindset that we've been sharing, ways of working, sharing methodologies, technologies, and this cooperation between the operators and vendors and system integrators is being great to have this opportunity and to improve innovation and to be future-proof in terms of technology. In terms of business, the current threat is the lock-in and high prices. Of course, this can reduce the costs of these implementations, but also in terms of interoperability, things work together. Things just work when they are on this platform Sylva. In terms of ecosystem, there is a fragmentation of solutions and the hyperscalers entry. What Sylva can bring also here is the common telco cloud technology. It's a baseline. It's not a standard on the paper. It's a framework that works and can end this fragmentation, but also to be a convergence between of the telco cloud layer and the applications. Last but not least, and this was a project that began in Europe, but of course can be exported worldwide. In Europe, we have a strong regulation, a lot of also cyber risk, but this is worldwide. And this project is also to be compliant with the European regulation that is very strict and also to be compliant with the high security standards. Our approach to this problem was to bet on the 5 technical pillars that you will see in terms of governance, the way that we organized. So in terms of network performance, we wanted for this to improve the network performance and to answer the special requirements from these applications, from the CNFs, and some features that are normally requested to be standardized and to be applied with a click. But also in terms of distributed cloud for the part of the declarative and the bare metal, but also for the part of optimizing lifecycle on the Kubernetes part that these applications will run on top. In terms of security, to be the best in class in security design, to answer the telco grade requirements. And as you know, these are very special applications. It has a very strict security and regulation, and needs to have the most higher standards to comply. To be open source and standardize the APIs to support any kind of vendor for the CNFs, and to also improve the market adoption. Last but not least is the energy efficiency. So also to begin to measure the application and have this observability part included in order to begin to understand in terms of KPIs how this energy efficiency can be improved. And of course, reduce the energy consumption. In terms of work groups under Sylva TSC, and I'm seeing now that we have here a typo because on security it shouldn't be Theophil. It's a new person here, but we are divided in the telco cloud stack that Matthew is going to explain, the validation center, also Luis is going to detail, and then we have the security, energy efficiency, communication and adoption, and evolution and governance. We are going to send you the correct slides. This has 2 typos here. And then we have this technical steering committee with Orange, Touch, Team, Telefonica, Vodafone, Nokia, and Ericsson. What we deliver and Sylva adoption's benefits and why there is such a big ecosystem and a lot of operators, vendors, system integrators, hardware and infra providers, why everyone is here because they all have benefits on the adoptions of Sylva. For the telecom operators, it's simple. It's to have a common cloud layer to reduce the costs, to create this cloud continuous for the capability, but also to be able to deliver new services, to have new markets, to go on this journey of becoming a techo, and to have the certification and cost time of a network function. For the network function providers, is to have what every network function software builder wants to have. It's to deploy, build once and deploy in many sites without any configurations or many specifications that needs to be changed. It will reduce the cost at the time, also in terms of certification, and provide environment tests and telco grade capabilities for the VNFs. For the system integrator, is a new business opportunity to create a distribution of Sylva, but also to support this kind of framework, and to have the interoperability and compliance that can ease the life cycle. For the hardware and infra providers, is to obtain information of this for this kind of telco grade capabilities, but also to show the hardware can enable the capabilities required and the standardization that can be leveraged using Sylva. So each one of them has benefits, and that's why we see this as a cooperation of sharing. We share knowledge in this project. We share ways of working because we are all winning, and we are all going to a direction that we all win by sharing information. In terms of synergies, you will see that Sylva is.
André, we've got a question from Victor Morales.
Victor? Sorry, because I'm on the office today. And
I can manage.
Perfect. Thank you, Guillaume. Sure.
No, sorry. I just hit the.
It was a test.
Sorry.
Ending. Okay.
So our process to reply to questions is working. So it's a good test. Sylva has a lot of projects that needs to be aligned, and we need to do this in the open source ecosystem in order for us to have a clear goal and to don't begin to do any kind of job that this other project accountability. We've been working, and we are inside of Linux Foundation Europe, what also leverages this knowledge, what is happening, but also to share insights between the projects and to create the full ecosystem, because Sylva is still part of an ecosystem. Help the operators and to boost the networkification, the virtualization of the network. And in terms of architecture, I would now, I think, pass to Mattia to begin to talk about a bit the architecture and our framework. Mattia, do you want to share your slides, or do you want me to?
No, I can use yours.
Okay.
I will share my screen if needed.
No, can use these ones. Mm-hmm.
Okay. So just to enter a little bit in details in what we want to achieve technically speaking. So we target to deploy some Kubernetes clusters on top of several kind of infrastructure. What we want to be able to manage are some Kubernetes clusters that we can deploy on top of bare metal environments or on top of virtualized infrastructure environments. We feel like it's important to be able to deploy those clusters on top of virtualized infrastructures, because we all have some virtualization solution, be it based on OpenStack or on a VMware solution, on top of which we'd like to be able to deploy such Kubernetes clusters for hosting central use cases. We can think about the 5G core functions are probably going to be hosted in virtualized in virtual machines. We think about the CU for our use cases. It's not something that is that has to be deployed very far from central data centers, so it can also be virtualized. But in addition to this kind of central Kubernetes cluster deployments, we also want to be able to deploy some clusters at the far edge. And for that purpose, we'd like to be able to manage some Kubernetes clusters on top of bare metal infrastructures. So we are probably going to work on optimized hardware for that purpose, for far edge purposes. But today we are already able to deploy some clusters on top of standard data center bare metal servers. At Orange, we are testing some hardwares from Dell, HP, Lenovo, and other telco operators are probably testing other materials. But we may work on using some specific hardware for the far edge use cases. And the purpose of this is, of course, to be able to host use cases and cloud native functions such as DU in the case of ORAN use cases, or remote UPF when we talk about 5G core use cases, for instance. We can talk about CDN instances also that can be remotely deployed on such infrastructures. Okay, just to tell you about the high-level design of Sylva. So the design we've been adopting is really about having a central instance of Sylva called the management cluster that is going to manage some remote instances of Sylva clusters called workload clusters. And the CNF will be hosted on those workload clusters. So in Sylva, what we are going to do is to manage the life cycle of each clusters. And we briefly talked about edge use cases. So when it comes to edge use cases, it will probably mean that we will have to manage the life cycle of 100 or even thousands of Kubernetes clusters. So we've been adopting this design, high-level design, for that purpose, in order to be able to scale in terms of number of workload clusters. We've been adopting also cluster API for managing the life cycle of each cluster, management cluster and workload clusters. We also want to manage the clusters the GitOps way. So for that purpose, we are adopting Flux as the tool to manage the GitOps workflows. So in Sylva, what you will do is describing the cluster you want, especially the workload cluster, in YAML file. And with the GitOps workflow, you will be able to reconcile the definition of the workload cluster with the real workload cluster deployed. So we want to host the definition of workload clusters in a central Git repository, and Flux will take care of this Git repository to tell cluster API and other components to adapt what the real workload cluster to what has been described in this YAML file. So it's kind of a standard GitOps workflow for those who are familiar with this approach. But this is really at the heart of Sylva. So adopting GitOps workflows with Flux as a central piece to manage this workflow, and adopting cluster API for managing the the life cycle of clusters with an infrastructure as code approach. So today in Sylva v1.0.0 and the v1.1 will be out very soon now, probably in the coming days, probably today, man. So what do? We are able to deploy some RK2 Kubernetes distribution or some KubeADM distribution on top of VMware infrastructures or on top of OpenStack infrastructures or on top of bare metal servers. And you can do it so in terms of infrastructure, you can do it on each cluster. You can have one workload cluster that is running on top of bare metal, while other workload clusters are deployed on top of VMware or OpenStack. And you will be able to manage the lifecycle of each workload cluster independently. This is important because we see that it would be really painful to have to upgrade, for instance, every workload cluster at once. We want to really go one workload cluster to upgrade workload cluster one by one or fleet by fleet, because it will ease the upgrade process and the upgrade strategy for our customers. So I only mentioned Flux, Cluster API, RK2, KubeADM, but we do have a lot of other components that makes Sylva. For instance, we are adopting Cert Manager, we are adopting Keycloak for managing the credentials, we are adopting Multus and SRIOV operators for the workload clusters that need to host some performance-oriented CNF. I'm thinking about UPF, for instance.
Maybe I think there are 2 points to see if the MD side has questions, right? So when Dominique presented, right, the first use case was around the proven box performing the compute itself. The second one is the proven box offering error protection.
Sorry, was it a question? I didn't get it.
David, we did not understand your 2 use cases you were mentioning.
No, sorry, I don't have a question right now.
Okay.
Okay.
It was behind you, sorry.
Okay, so this is what we have in the stack today, and we are going to probably evolve with some interesting work in progress coming from Red Hat and probably other partners coming soon. So we do have a request for announcement into Sylva today to be able to manage some OpenShift opinionated workload cluster, for instance. We'll see how it goes, but it's under discussion. Because today, you know, we have RK2, which is kind of a SUSE and Rancher opinionated version of Kubernetes. But of course, other key players of this ecosystem do have their own flavor of Kubernetes, and we are discussing with them.
Yeah, I just wanted to be sure, like, I hope you don't have any dependency on chipset, right? Whether I use ARM or AMD or Intel, do you have some dependent component on chipset, or is it okay to use any of them? And can we use them together as a hybrid environment?
Dependency on ARM or Intel hardware?
Yeah.
Today, we only support x86 hardware, but so the tests we do at Orange are based on Intel CPU and chipset, but nothing prevents you to do the same on ARM as long as it is as the components we have are compatible.
Yeah.
But I'm not sure any of the telco operators are doing some tests based on ARM CPUs.
Yeah, and Matthew, and perhaps the question of Ayush is in the future, if we want to raise the Open RAN use cases, we have planned to integrate some real-time operating system, but are we open also to have in our validation center different kind of chipset architecture to provide the best efficiency in terms of energy and performance for the RAN use cases? Was it
Yeah,
your
so that's
question, Ayush?
yeah, so that's where I was going slowly.
Yeah.
Like when you talked about energy saving, I
Yeah.
was wondering like if you are also considering using ARM for that, depending on RAN use cases mostly. Yeah.
So definitely on the RAN use cases. So we last year we were very focused on 5G use cases, and now this year we are integrating RAN requirements. So definitely when we will have in our validation center some platform more dedicated on the very far edge for the DU of the Open RAN, we will open the door to new kind of hardware architecture, including SmartNIC, but also chipset.
Yeah, I was wondering that because when you told cloud consortium, so if you have core and RAN on same platform, so I was wondering like if you go for RAN, it will be like if you go energy saving, some customer might be requesting, okay, ARM is better, and maybe for data center you might be using Intel or AMD. So I was just wondering about that. Yeah, thank you. So when in future you have some plans, not concrete, but you might have some plans, right? Yeah.
And again, as mentioned by André, we are here in and Luis, we come back on this on the validation center. Also to work closely with the different vendors to see the trends in terms of hardware architecture also. So we are very open to test new kinds of hardware and to integrate if they have specific technical requirements in the stack. I do not know, and Matthew can complete it. We will manage this.
Yeah, sure. I think the Kubernetes community is maintaining some flavor of Kubernetes compiled for ARM chipset. No?
Yeah, they have Hypercube, if I am correct, which are being maintained for ARM.
Okay.
Yeah. Yeah. Okay. Thank you.
So again, if it's something that is mandatory for the CNF, we will definitely consider it.
Yeah, sure. Thank you.
Okay, so one of the main components that we are releasing is a Sylva unit Helm chart, which is hosted in the Sylva Core Git repository. And this Helm chart is really about taking the cluster definition into account to deploy the corresponding Flux objects for deploying the corresponding cluster. So depending on how you define the cluster you want, if it's if you need kubeadm and not RK2, if you need to deploy on bare metal, or if you need to deploy on OpenStack, or if you need to deploy Kubernetes 1.27 or another version, this will be defined in the workload cluster definition. And based on this definition, the Sylva unit Helm chart will deploy the corresponding what we call Sylva units for your your workload cluster to be efficiently deployed. Because depending on the definition of your cluster, you won't have the same Sylva units needed for it to be deployed. For instance, if you want to deploy on top of bare metal, you will need to have in the management cluster metal cube deployed. But if you want to deploy on top of OpenStack, you will need to have cluster API OpenStack provider deployed. So it's not the same story, and we are managing the dependency of each component depending on the workload cluster definitions, thanks to this Sylva units and charts. So this is really the heart of Sylva. If you want to start digging into what Sylva is, how we deploy clusters, the entry point is the Sylva core project. And we also have a technical documentation portal that you can start reading to get familiar with the technical component of Sylva core. It's not fully mature for the moment. We need to give it some love, but this is at least an existing entry point. And of course, with this technical portal plus the Sylva core project, you can start deploying some Sylva clusters, both management clusters and workload clusters. And of course, we are always available on Slack channels. If you need to discuss about technical components, if you have some technical questions, don't hesitate to get in touch with us, especially on the dev channel. You will have access to every Sylva developer here. And I think that's it. Yeah. Is there any other technical questions about the Sylva stack?
Okay, so I can tell you what is the validation center or validation program within the Sylva project. As Mathieu and Andre have been commenting, Sylva aims to release an open source software reference framework. So once we have this reference implementation, we can actually deploy it and use it to validate that network functions, workloads in general, can work on top of this stack. So Sylva is building a stack, is providing a reference implementation, and with this reference implementation, we deploy it in on top of some hardware, and then we can demonstrate that workloads can be deployed there. So because this reference implementation is a cloud native implementation that incorporates the characteristics, the capabilities, the features required by the telco workloads, such as depending on the use case that we are incorporating. We have already incorporated those for 5G, the accelerators. Now we are incorporating those for Open RAN, PTP, for instance. And we are also incorporating things that are required by edge applications, for instance, support for GPU cards. So when we implement this, what we in a hardware, we create what we call a platform, a validation platform. And then we use this validation platform to validate workloads, network functions. We have been validating so far 5G network functions that they are cloud native. But just following one of your questions and the comment from Guillaume, we have not only one validation platform, we have different validation platforms. We have one that is an implementation of Sylva on top of bare metal. We have another that is an implementation of Sylva on top of virtual machines, on top of IaaS, we call it, and on top of an open stack. We call it another flavor. We have also an implementation that is with Dell hardware, another that is with HP hardware, and moving forward, we can incorporate also AMD or any other type of hardware. Right now, we have different platforms to have different configurations of the same features. So with bare metal or not with bare metal, with one hardware or with another hardware, I mean hardware vendor. Because the idea of Sylva is to demonstrate that network functions can be deployed or workloads can be deployed in an agnostic manner. So they can work in different hardware, for instance. So they are cloud native. So that's the intention of the validation center, to demonstrate that the workloads can work on top of Sylva stack, being the reference telco stack. We are running this validation as the reference implementation implemented or instantiated with a specific hardware. And we are running these workloads on these platforms. Important. We are not just to validate one workload and say, okay, it is validated. Doesn't mean that we are going to pass them through all the platforms. It's up to an application provider to indicate what is the normal use case where they will be used, or maybe an operator expects to be validated that it is working in a given configuration. But there's no need to run through all the platforms. And another important thing is that this is called specifically validation and no certification, because we are not running a complete check of all the functionality of the workload, of the network function. We are not testing the network function. We are only validating that it can be deployed on this Sylva stack, and there's nothing preventing it to be deployed and working as it should be working, but with minimum testing. We don't do performance tests, let's say. This performance test is to be done by an operator previously to deployment, production deployment, if they seem required. But here we don't do any performance test, just basic functional testing. And we are trying to use existing standards or existing assets in the industry. So for instance, we are leveraging the ANUCET, now called CNTI, assets, and we are running the CNCF test suites from there. We are also testing that the workload follows the cloud native principles. This is something that we do. We run the scripts for cloud native first. This is the current validation program. The validation program has another part that still has not started, which is demonstrated that any distribution that may be created out of Sylva incorporates all the features that have been defined by Sylva. So basically, it's running the same workloads on this distribution to confirm that they still work there. So nothing has been changed when anyone has created a product, let's say a distribution out of this open source reference implementation. This second part, what we call the derivative stack validation, we have not started yet. This is something that will be done when we have different distributions or products created out of Sylva. Right now, we are concentrated on the workload validation, which is what it is ongoing. There's a question there. What was the question? I saw it briefly. Who are expected to host the validation platform? Good question.
Yeah.
The validation platform is being hosted by us, by Sylva, by the working group. So right now we have one validation platform two in Telefónica and 3 in Orange. Actually 1 and 2, but we are creating a new one in each one of them. And team is also creating or preparing, setting up its own validation platform. So for instance, the one in Telefónica is the one for OpenStack. We have an OpenStack version with some HPE hardware, and we are now creating another one with their hardware. Orange has a validation platform, 2 validation platforms for with Sylva on top of bare metal. So who is hosting it? We are hosting it. Sylva program is hosting this. We are trying also to automate this. Yeah, one question.
Yeah.
There was one question.
If we want to add the platform we want to validate, how should we do?
Okay, within the validation group, you propose to create a new platform, and we are open to have new validation platforms onboarded. So from then on, you can test or run some of the workloads. And the good thing of this is, if you have run it on Sylva, let's say on bare metal, we don't need to run it anymore. So Orange will not need to run that because we all accept that this has been let's say, validated in your configuration. We will generate, or you will generate, a validation report, and we post this. Actually, we have an area in the Sylva work group environment where we publish all the validation reports indicating in which configuration every workload has been validated. And right now we have validated those that you have down there, something from Nokia, from Oracle, and from Syswind in different configurations.
Okay. And one more question. It's just about from curious, but if I want to add my platform to this validation platform, is that possible?
Yes, it is possible. So each validation platform is an independent, it's a hardware that you have in your lab, let's say, same as the one that we have in Telefonica. It's in our lab, and we just indicate that this is a platform. So the working group, when we need to validate a new network function, we allocate it to you. It is your responsibility to have Sylva stack deployed in your hardware, and then demonstrate that you are deploying, onboarding the network function. You create the report, the corresponding report, and you run the functional test, the needed corresponding functional test, and finally create this validation report. And you will be responsible of this platform. One additional thing that we are doing is that we are trying to automate this so that we will have a portal where all the platforms will be registered. It still will be your platform, but you will access to your platform through a common portal. This common portal will have a authentication mechanism so that you can only access to your platform, let's say, not to others' platform. But at least we can centralize the access to each one's platform and the generation of the validation reports. But yes, if you want to have a validation platform, it's very easy. You can have it, and we are open to have more validation platforms. Mostly, if you are interested in having a different configuration, let's say, instead of bare metal with Dell or with Lenovo, you want to have bare metal with AMD, as you discussed before. That would be fantastic, because it's an additional configuration of Sylva where we can validate workloads. The idea is that if a workload is validated in several configurations, it is more cloud native than it is validated in just one configuration.
Okay, thank you.
So we can go back to the slides.
Yeah, and on this part, maybe we have also some questions on the workgroup one. So Matthew, if you can start to answer to this. We have a first question about does management cluster expose any API so that CNF could be deployed, and I think deployed automatically, so it's relatively linked of what you mentioned, Luis, on the fact that we are targeting to have a more automated deployment of CNF also, because Sylva, the real focus is on the telco cloud part, but without a smooth CNF onboarding, it has little value. So we are all aware about this. But Matthew, you can also share what we intend to do also on the workgroup one about the lifecycle management of the CNF.
Yeah, we do have multiple strategy to handle CNF deployments. Because the first one is to get in touch with the Nefio project. So we are discussing with them. We made some demo of coupling the Nefio with Sylva, because I'm not sure everybody is aware of what is Nefio, but Nefio is a way to manage the deployment and the configuration of CNF, and it can also manage the deployment of the cluster itself that will host the CNF. So we are discussing with the Nefio community for them to rely on the APIs that we provide to deploy those workload clusters for hosting the CNF. And we will, but moving to Nefio is a may be complicated, especially for CNF vendor, because it needs the CNF packaging to be revisited to be compatible with the NIFIO technical strategy, which is based not on the Helm charts but on KPT files. So we may come also to some other projects that are more in line with what we see from the CNF vendor industry to rely on what they provide for deploying the Helm chart they are providing to infrastructures vendor.
So in a word, we want to apply the same principle of we manage infrastructure to the CNF with the GitOps deployment.
Exactly.
Okay. So I hope we answered to your question. It was on Subhash Kumar.
Yeah.
Is it okay? Okay. And
just to emphasize one fact is that
okay.
is that today at Sylva we are really focusing on the infrastructure layer, managing the life cycle of the CNF itself is not in the scope of Sylva as it is today. We may evolve, but we are really focusing first on being able to do infrastructure as code with GitOps principle and focusing on providing some clusters that can host the CNF with the good technology needed by CNF themselves. So this is why we don't prioritize any work on the life cycle of the CNF.
Okay, thank you for this precision. We have another question from Laurent Boutet. So he starts to install Sylva on his laptop, on his dev laptop, with the issues of how we can manage to support newcomers.
Yeah, so first, thank you for testing. So on laptop, you will probably have to use the Sylva flavor that we use for development and test purposes on small environments. So it's based on kubeadm plus Docker infrastructure. So for those who are familiar with cluster API, we are using capd for that purpose. So it is tested in CI and it should work fine. There is an how-to in the Sylva documentation portal for that.
Yes, I saw that.
And I see that you are
there's a
testing
Slack
also.
as well, but there's a Slack channel where you can contact.
Yeah.
Just like
yeah.
by
there is a
the
Slack
way,
channel
I use a VM of just to have a bootstrapping, and I push that on OpenStack systems. So it's why I have some issues sometimes with the preparation of OpenStack, some issues concerning drops resources or this kind of things. Sometimes it's quite difficult to find where is the logs or where we have to check the system. So it's why I think perhaps I'm now in an issue where I don't have any idea where to looking for why it doesn't work. So yes, I start to know where could be the good channel or a good way to have some help to facing some errors, just to know where to look.
Slack channel is definitely
the best way.
The way to contact the developers that will definitely help you. And we know that it can be a little bit weird to debug, especially when you face issue, because Flux as an orchestrator is handling all the deployments of all the units, the components that make a Sylva cluster. But then when something is going wrong, it can be difficult to know what went wrong. We know that we have the same issue, so we are trying to improve the troubleshooting guide, and we need to make the technical documentation portal evolve that way to help newcomers, especially. Yeah, we know that. But
Yeah,
today,
because
don't hesitate to contact
there's
us over
so
Slack.
many
to help.
possibilities now. It's not too
Exactly.
difficult to check what kind of components.
But-
So I am in the clustering config creation. I have the instantiation, but after there is a lot of running tasks behind of that.
But good news for you. OpenStack infrastructure is probably what we, at least at Orange, are testing heavily. So
No, pretty sure. It seems to be stupid things also based on the fact we need to have some enough resources. I think it's perhaps an issue concerning resources or some policies or whatever and this kind of thing, because it is a lab. It's not something where there is a huge capacity, but it's typically the issue when you have to use a lab. So okay, but that's like it's the way I would start. Thanks.
Yeah, please. And there is another question related to understanding the CNF deployments. So today, when you deploy a workload cluster that is supposed to host the CNF, once it is deployed, you will have to provide the corresponding kubectl to the admin that has to deploy the CNF on this workload cluster. And you will probably have to play with Rancher on the management cluster, Rancher and Keycloak, which are hosting the airbag solution. In order to, it really depends on the CNF. If it comes with specific CRDs, especially, and if you need to access the API defined in those CRDs, you will have to tell Rancher to allow this access, because as it is today in Sylva, and it may evolve, we do have discussions about that. As it is today, the workflow for accessing a workload cluster is going through the management cluster with a Rancher, especially on the management cluster, taking care of the authentication and the authorization of this end user to access this workload cluster. This is the way it works today. So this is why you may have to manage the Rancher authorization for accessing the CNF, the workload cluster, and deploying the CNF. There are some alternatives that we may discuss, and some propositions from DT, for instance, at Deutsche Telekom, to provide access with access control and authorization directly on the workload cluster itself. But this is not part of Sylva today.
Okay. So thank you, Mathieu, for these precisions. So maybe I will switch on the next slides. Just to share to you where we are in terms of adoption. So we have many active contributors among the IT vendors, network functions vendors, and we have now opened also the opportunity for some partners to be also financial sponsor of a project. So we have now a dedicated budget associated to the community project. And the premier sponsor are listed here, and the general sponsor are listed here. So it allows us to extend our adoption within the ecosystem. It's mainly the objective of this dedicated budget. And The ecosystem is still growing with new interested operators and vendors, and also integrators. So don't hesitate to as potential partners to also extend this ecosystem. And in a world where we are today, so this project is 16th month project. We have launched it in the Linux Foundation. We have already 3 major releases of the stack, and Matthew mentioned what we delivered in February, the V1 of the project. This V1 will be deployed in production for 1 and maybe 2 operators this year. So one Orange will deploy it in production in H1, and another operator is evaluating the opportunity to deploy it in production also in H2. So we are not only an open source project, we are really focused on production deployment of this solution in the short term. And mentioned by Luis, we have many validation centers that have already opened, but if entity wants to open one, they are very welcome also. And what is in front of us, as I highlighted before, we were very focused on 5G core use cases this year, but definitely we want to reach the Open RAN ecosystem. And it's our priority this year in the development of a stack with integrating real-time OS, but also in the validation center with new partners to test the solution. And that's it. And we will share all the slides, the link. We are a community. And André share to you the 4 working groups. So we have dedicated meeting for each working group. So don't hesitate to coming back directly to the leader of a working group if you want to be invited, or just send a message on the general section of the Slack, or email André, me, or Matthew, Luis. Don't hesitate to contact us directly. So that's it. Any last question? Because we are on time. Many thanks to André, Matthew, and Luis to present the project. Carlo Cavazzoni, the other co-chair, is also on the bridge. And we say bye-bye, and you will have also access to the record of this session. Thanks all.
Okay. Thank you. Bye.
Thank you. Bye.
Thank you.
Thanks everyone.
Bye-bye.
Bye.
Thank you.
Have a good
Thank you.
day and night.
Bye.
Thank you. Bye-bye.
Bye-bye.